Welcome to solverfy.
In this problem on the topic of oscillators, we want to calculate the phase angle phi naught for a forced oscillation at resonance, that is when omega is equal to omega naught. We then want to know the displacement at a time when the driving force is a maximum and at a time when the driving force is equal to 0. Lastly, we want to know the phase difference between the driving force and the displacement in this case. Now we can calculate the phase angle phi naught using the equation that we've learned, and this is the arctan of omega naught squared minus omega squared divided by omega into b over m. But remember, at resonance, we have omega to be omega naught, the resonant angular frequency. This means that the phi angle, or the phase angle rather, phi naught, is equal to the arctan of omega naught squared minus omega naught squared divided by omega into b over m. We can see that this is simply equal to 0, and so the phase difference is 0. Next, for part B, we want to know the displacement when the driving force is a maximum and the displacement when the driving force is equal to 0. If we have omega equal to omega naught at the resonant frequency, we had this driving force F ext to be F naught cosine omega naught times t, and the displacement x is equal to a naught sine omega naught times t. Now the displacement and the driving force are a quarter cycle or 90 degrees out of phase with each other. So this means that the displacement x is equal to 0 when the driving force is a maximum. And the displacement is a maximum when the driving force is 0. Lastly, in part C of this problem, we want to know the phase difference between the driving force and the displacement, and as mentioned above, the phase difference phi is equal to 90 degrees.